All right, here, folks. Let's take a few minutes and take questions from the assignment from last time. So if anybody's got anything from 30 whatever to 40 whatever.
32 to 43.
Yeah, sure.
36 to 43. Can you just use
you should be able to do it algebraically, like that will be the expectation on the test. But yes, you could certainly use your calculator to kind of give you some clues as to what you should be looking for. Caitlin? 43? Sure. Okay. So the first thing that I notice if I look at the coefficients here on 43 is that there's a greatest common factor of 4. So I'm going to factor that out. Okay. And now what I'm going to do is I'm going to make a list of my possible rational zeros. So those are my possible rational zeros. And what I'm going to do is I'm going to cross-check these to what I see when I look at the graph. Okay? This will give me an idea of which one of these are good candidates to do the synthetic division with. And which one of these are ones to kind of stay away from. So that's there. And I'm going to pick a window because last time I was using my calculator, I was doing things where I was changing the window, so I know I'll probably need to do that. For the x min, I'm going to just pick something a little bit smaller than the smallest number on this list that I have here. So the smallest number on this list is -4. So maybe I'll use -5. The biggest number on this list is +4, so I'll use +5 for the x max. And then for the y min and y max, I just really need something that's negative and positive because all I really care about is where the graph is crossing the x-axis. So -5 and +5 look good to me just for symmetry's sake. So if I look at this, I have something that's a little more than -1. Or I'm sorry, yeah, so maybe -2/3 might be a reasonable guess. Let me just pull up my stuff so we can write some of this stuff down that we're seeing. So looking at the graph, we see x equals -2/3. Maybe. It's hard to tell if that's exactly -2/3 or not, but maybe. I see something over here that's a little bit more than +1. Well, that could be 4/3, right? Maybe. Could be. And then this thing that's a little, maybe 1.5, right? Maybe. Hard to tell, right? Is everybody okay there? Now, this thing doesn't seem like it matches up with anything on my list, right? If I go and I compare this to my list, it doesn't appear that that is on my list anywhere. You guys agree with that? What does that say about this value? That tells me that this is irrational. That means it's going to contain like a square root or something. And it's not going to be a number that I can use the synthetic division with. Okay with that idea? In addition, I also know that irrational solutions come in pairs, so they're never by themselves. So there's going to be another irrational solutions amongst these two. This one seems like the more likely candidate because this one looks much more like 4/3 and that one did like -2/3 to me. The other one looks a little bit too close to -1 for me to think that's -2/3. Is everybody okay with that idea? All right. So this is the one that I'm going to try my synthetic division with. Well, we're looking for the solutions. Yeah, we want it to work. Ideally, it should. So there's my coefficients. Notice I took them from the factored form and not the original. You could still take them from the original, but it just makes the arithmetic a little bit more tedious because the numbers are bigger. So I'll bring down the 3. And then 4/3 times 3 is 4. 4/3 times -3 is -4. And then -3 times 4/3 is -4. So that worked. So what I can say here then is that 3x cubed minus 7x squared plus x plus 4 factors to x minus 4/3 times remainder constant x coefficient, x squared coefficient. So I have that. Is everybody okay with how I've gotten to here? Okay. So this is nice because both of these polynomials that I'm left with now are easy to solve. If I set this polynomial equal to 0, I obviously get x is equal to 4/3. So there's one solution, and that matches up with what we saw in the picture. To find my other solutions, I'm going to set that quadratic equal to 0 and solve that. Now notice here in this quadratic that there's a greatest common factor of 3. So I can just divide both sides by 3. And I'm left with a quadratic that's not factorable because there aren't two numbers that multiply to give me -1 and add to give me +1. Actually, I should say two integers. What should I do to solve this if I can't factor it? The quadratic formula. Very good. So when I do that, I get 1 plus or minus 1 plus 4 over 2, or 1 plus or minus the square root of 5 over 2. Coincidentally, if I go and I get a decimal approximation of those two solutions, 1 plus the square root of 5 over 2 is about 1.6. That looks like this guy, right? That's just about the same thing as what we thought there. And if I do 1 minus the square root of 5 over 2, I get that, which is very close to what I thought the negative 2/3 was. So I have all three of the solutions that I'm looking for. I found their exact answers because I used factoring in the quadratic formula rather than just using my calculator to get these. In addition, Matt, if you used only your calculator, you could potentially miss if there was imaginary solutions.
Yeah.
So we do need to be careful there about that. The only way you're going to be able to get to those imaginary solutions is to go through the whole algebraically. Okay? Kendall?
What was the first solution?
So we found 4/3. And then the second one is x plus the square root of 5 over 2. The third one is 1 minus square root of 5 over 2. Right? Because of the plus or minus, this is really two solutions here.
Oh, no.
Right? One where we're adding, one where we're subtracting.
So what happened to the
Well, negative 2/3 was not what that was. What this was 1 minus the square root of 5 over 2, which is approximately negative 0.61.
where did you decide to use
I just guessed. When I looked at the picture, it looked closer to 4/3 than that other one did to negative 2/3.
So there were
Yeah, I just, part of it was that I knew that this guy was irrational because it wasn't close to any of the things on my possible rational zeros list. So I knew one of the other two was also irrational. So I looked a little bit closer and tried to see which of those x-intercepts, looked closer to negative 2/3 or positive 4/3. And I thought the positive 4/3 I felt better about. It looked to me more like positive 4/3 and the other one looked like negative 2/3. I thought the other one was a little bit too close to the middle, looked a little bit too close to the middle of between 0 and negative 1. But I very easily could have been wrong. If I didn't get a remainder 0 here, I would have just gone back and tried negative 2/3 then. Does that feel okay?
yeah.
Okay. And in general, usually the irrational solutions, if you have one that's positive, usually the other one's negative, which is another. Now that doesn't have to happen all the time, but frequently that's the case, which made me feel like the negative one is probably the other irrational that went with it. So another check towards trying 4/3, other than just using my eyes. Okay. Do you want to do some more of these? Is there another one that we want to do?
Let's say 41.
41? And just FYI, I wrote down a lot of stuff there. You don't necessarily have to write down all those steps that I just wrote down, but I wanted to make sure that it was pretty clear what it is that I was doing. Okay. This one maybe we can do without writing as much down. So again, we're looking for all the zeros for this function, so we want to find all the values for x that make f of x equal to 0. This one, actually, I look at this and I don't even have to do any divisions at all. I can factor this without having to do anything. So if I have 4 terms like this, if I'm not going to use like synthetic division to factor this, the factoring technique I would try is grouping. So what I'll do is I'll group the first 2 together, and then I'll group the second 2 together, and look for a greatest common factor in each place. So in the first group, I see that I have an x squared in common, and in the second group, I see I have a negative 3 in common. And I know I can continue and use this factor by grouping technique because I have a common factor here on this step. Also, if those two polynomials were different, you can't do factoring by grouping. You've either made a mistake and not factored enough or did something else wrong, or it's just not one that can be used, you can use grouping on. So on 43 that we just did, you couldn't have done that one by grouping. We had to do the synthetic divisions for that. But here, we can do this a little bit easier because we're able to just factor that polynomial right from the get-go without having to do any synthetic divisions. And now that it's in factored form, I can just set the two factors equal to one another. So one solution is -3. And to solve that second quadratic equation, I notice that there's no x, there's just x squareds. So I can just solve this directly. So I can add 3 to both sides and then square root both sides. Remember, when I square root both sides of an equation, though, that creates a plus or minus. So there's my zeros. That's all we had to do for that one. We didn't have to, we were able to do it without doing any synthetic divisions. Now, you certainly could have done this with synthetic divisions. Would you like to do that?
So, in the beginning, what we should look at is we can factor anything.
Yeah.
And then after that, if we can't factor it down like this, then we should do like the
Synthetic divisions. Yes.
little bit like the most complex factors in that.
Mm-hmm.
And we would check it.
Mm-hmm.
And then we would check the
Mm-hmm. Yes. When you find something on the calculator that matches something on the list.
all right.
But if you can factor it to, into like linear and quadratic pieces, those things we can solve very easily. So we can just stop at that point. We don't have to use the synthetic divisions if you can do that factoring. Does that feel okay? And in general, that would be my preference if I was doing these problems, is I'd rather not have to do the synthetic divisions, because it's a little bit more time consuming than to just factor it by hand, or factor it without doing that, using some of these older factoring techniques that we learned last year or the year before. Okay there? Okay. Any more questions from this assignment? Okay, sounds good.